So probably I will not be checking the chat. So please better raise your hand if you need to ask something. Okay, but if I can notice something in the chat, yeah, I will answer. Okay. Okay. Good. So. Uh, okay. So the topics that we are going to discuss today are these, and yeah, let's start. Okay. So first, this is a very simple example that probably some of you already have addressed. So my question for you is, how do you find a model that is able to classify between these two classes? So we have just data points which are two-dimensional, okay? They belong to two classes, red and blue. And what I have to do is to build a model that, given a new point, I have to assign the class, either class blue or class red. We can talk actually about positive class, for instance, for the blue, and negative class for the red. Okay, so that's the problem. That's a typical problem in machine learning, a classification problem. For instance, this could be representing emails and email messages. We want to classify them either as spam or as uh, normal messages. Okay, so yeah, there is a process of feature extraction to extract some features. In this case, only two features. Okay, and then based on that, I want to build a model. Okay, that is able to classify the new message either as a spam or as a normal message. Okay, so that this is a typical problem. So my question for you is, how do you build a model for this? I just want to listen to your answers. Yeah, it's a very simple question, by the way. So don't worry if you think, but yeah, this is very simple. I will apply this or this. Okay, so how do you solve this? Yeah, you can use the chat if you want. Uh, okay, Joseph.
Hi. Well, I think you can use, as they say in the chat, a linear model for split the graph.
Okay, so a linear model. So what kind of linear model? Yeah, that's good. Perfect. Yeah, because a linear model seems to work here. So what kind of linear model?
A simple linear model. I don't know how to say in English.
No, yeah, a linear model will be, if I understood well, just to find a line,
Yeah.
right, that separate the two classes, something like this, right? Okay, yeah. So how do you find that how do you find that line?
You can find an intercept with the y-axis and also an slope from the line to try to.
Okay, so but how do you find the intercept? Yeah, because yeah, the parameterization of this line is something like y is equal to a times x plus b, right? And b is the intercept and a is the slope. So how do you find a and b?
I think with the minimum squares algorithm.
Mean square. Okay, so yeah, for instance, in my problem is a regression problem, right? Something that I can do is, let me move this a little bit. Yeah, for a typical regression, right? So yeah, I'll move that and I'll move it back again. So for instance, if I do regression with these points, ignoring the class, what I will get is something like this, right? A line like this, right? Something like this. If I do regression, right? And yeah, to do regression, I do yeah, the minimum square that is basically to minimize this distance, right? of a point to the line, right? And yeah, I minimize that for all the points. I find the line. Yeah, if I'm doing regression, right? But I'm doing classification. So how do I use this or any other strategy to find that line? Okay, how do you do that? How do you do that? Oh, sorry, Juan Sebastián Hernández.
Okay, I'm not sure that is the answer that you're looking for, but we can apply a logistic regression model.
Yeah, that I was expecting that answer. Yeah, we can use you can use, for instance, logistic regression. So, what does logistic regression do? So how does it work inside? What's inside logistic regression? What does it do to find those values?
It takes a line, a random line in the I would say workspace, and slowly changing the parameters to adjust the line.
Slowly. How slowly? I mean, why
within
how,
steps.
Oh, steps. So it changes the parameters A and B. Okay.
A and B, and adjust the line. So
how is that done? How do you change the parameters? Yeah, you start with random parameters. So how do you change those parameters?
We have an error function that we want to minimize.
Okay, so question, Juan Sebastián. The function that logistic regression is looking for is this one?
Is in my prior experience is this with a random extra term, an extra term, not random.
An extra term, but I mean you have you can add a C, for instance, here, right?
Yeah, in the chat it is Luis Alejandro.
Oh, yeah.
W0 más plus W1 por X, bla, bla, bla.
Oh, so it's not the same. So it's not, yeah, because an extra term will be a C, but you can put the B with the C. So what's the difference with what Luis Alejandro is saying? Yeah, because I had Y and X, right?
It can be because you take. Sorry if I talk. You take one of the.
Who's speaking?
Alejandro.
Okay. Yeah. The reason I asked you to raise your hand is because I can see your name here. Okay. That's why.
I will write the has.
Okay, Luis Alejandro. Right. Okay. Tell me.
Digamos the fórmula I write. Make a relationship with the two futures and the
right,
output.
But
and the output.
Luis Alejandro, can you write it again using two features Y and X?
No,
because
yes, I will be doing this. I will say that the difference is that in the slide the relation is between the two features, not the two features and the target. So I will correct.
No, hold on. You're right. The only thing which is wrong with what you put in the chat is the fact that the name of the features here is white and X. That's all. But this exactly what you said is the relationship of two features, Y and X, with a target, which is the label. Okay, positive or negative. So you are completely right. So let me rewrite what Luis Alejandro wrote there. So what Luis Alejandro wrote there will be something like this, like the prediction. Yeah, I will call f of x, right, is equal to W0 plus W1 x plus W2 y, right? So it's exactly what Luis Alejandro wrote, but with the name of the feature that we have here, x and y. Okay. So Juan Sebastian, so this will be the function that we will look for, right? Using logistic regression.
Yeah, that was the one I thought for.
Okay. Question. Since okay, but let me, yeah, before going to there, I noticed that somebody say centroids. Yeah, that's actually a possibility. Okay, there are different possibilities to solve this. So one possibility is that, let me see if what I interpret as centroids is what Gabriel Andres is thinking about. So that will be something like this. I calculate a centroid for these points. For those that don't know what a centroid is the center of mass of those points. That will be like the average of the x coordinate and the average of the y coordinate for the elements of the blue class, and same thing for the red class. The centroid will be something like this, right? So if I have the centroids for a new point, I can do what? For instance, I have a new point that I want to classify. Let's say this one. So yeah, probably let me. For instance, this one, I calculate the distance from this point to this. Okay, and the distance from this point to this, and then I assign to the class such that the distance to the centroid of that class is minimum, right? Is that what Gabriel was thinking about?
Teacher, I have a question.
Gabriel?
No, Juan
Raise
David.
your hand, please, to know who's speaking. Juan
Okay,
David?
sorry.
Yeah. Go ahead.
Okay, how do you know to get those centroids? Because if you have the points in the Cartesian plane, how do you know to see the partition of the points?
Oh,
Because
that's important. Yeah, let me clarify, Juan David. So
Okay.
what you receive is this: you receive the points, and you know to which class each point belongs. So you know that these points here belong to class positive, and these points here belong to class negative. So you know to which class each point belong. Okay.
Does mean that I receive the graphic like this?
Yeah, the information that is in the graphic, that's what you receive. Yeah, for instance, we want to build a classifier for spam emails. So I have a set of emails which are spam. I have a set of emails which are not spam. So I have samples from both classes. Okay. And the thing is, I want to, given that, I want to build a model. Okay.
Because I was thinking that we can get the regression linear, and we can get the perpendicular line. The problem will be the parameter b. But
right. Yeah, that's
line. Yeah, it will.
Yeah,
be like
yeah. I mean, what you were thinking about was something like this, like having a line,
a regression linear.
Yeah, like this.
Get the perpendicular
something
line,
like this, right? Yeah, to separate, right? Right. Yeah. That's actually a kind of similar to what we are doing with the centroids. But actually, what happens with the centroids is that the centroids help us to know which is the B that you will be missing if you just do regression. Okay.
Okay.
So yeah. For instance, if we do this with the centroids and we assigned the point to the closest centroid. So how is there is a separation boundary between the two classes. So how is that separation boundary for this classifier based on the centroids? Anybody can tell me?
Please, can you repeat the question?
So, is it clear how the centroid classifier works? I'll repeat it. You calculate the centroid for class, positive class. You calculate the centroid for negative class. When you have a new point, for instance, like this one, and you want to classify it, you measure the distance between that point and the positive class, between that point and the negative class, and then you assign the point to the smallest distance. Okay. In this case, for instance, you will classify this as red or as negative because this distance, this distance is smaller than this distance. Okay. So that's my classifier. So what I'm saying that this is going to define a boundary. A boundary like one region is negative, one region is positive. How is that boundary between those two regions is what I am asking for this classifier.
If you have the centroid, you can get the half point between the
exactly.
those.
Right, exactly. So you draw a line between them, then you have like the middle point here, and then the boundary will be the perpendicular line between those like this. Okay, that will be the boundary for the centroid base algorithm. Okay, is that clear? That will be the boundary. That line which is perpendicular and goes through, which is perpendicular to the line that connects the two centroids and goes through the middle point. Okay. So that's a possibility. That's a possibility. Do you see any problem with this algorithm, with the centroid algorithm? Juan Sebastián Malagón.
Maybe in the algorithm, I don't know how to say that. Sesgo.
The bias.
Have bias because the line that you define with the algorithm is not minimizing the error between the separation classes. It's only taking into account the centroid of the of all the classes, no? So
that's right. That's right, Juan Sebastián. So you will find cases where actually the centroid doesn't work well. Okay, we will produce strange results. So it's not taking into account all the points, just the centroids. Okay. Camilo says something in the chat. So please, can you turn off your mic? Juan Sebastián, thank you. So Camilo says something in the chat, which is true and it's important. This line here, this line, right? The line here, better here. This line is exactly the points which such that their distance to the positive centroid is equal to the distance to the negative centroid. Okay. So that's like the boundary of in that case. Okay, so let's go back to our previous formulation based on trying to find these parameters. Okay. Something which probably is not clear, and I want to ask you is this is the formulation because this is my prediction, and this is a linear term on the features, okay, on X and Y. But the equation of a line is this one. So what's the relationship between this and this? Anybody can tell me? Anybody can tell me what's the relationship between this and this, Camilo?
If it's a generalized linear model,
okay,
and you need, after this model, you need an activation function.
Hold on. Okay, so yeah, I'll make my question more specific. How do you, from this one, let's say I give you this, I give you W0, W1, W2. This is going to define a boundary which is linear, right? So from this one, I want to get this one. How do you get it?
Okay. The x in y, it's a vector which all the features from x. I mean,
No, you mean these sets?
Yes.
No, this is not a vector. This is a scalar. This is this one, and this is y. Which this s is equal to this x, and this y is equal to this y. So what I'm asking is, I give you W0, W1, and W2, and I want to get A and B. How do you get it? Joan Sebastian.
Yes, Professor. If I take W0 as B and W1 as A.
Okay, so yeah, hold on. W0 as A,
B,
W0 as B.
Yes.
W1
A.
And W2?
W2 0.
What do you think, guys? Yeah, that's a possibility. The problem is that you are totally ignoring Y.
But teacher, I think that there is a problem there because you are creating a function.
So who is talking? Camilo?
Juan David. Sorry.
Juan David. Yeah, Juan David. Oh, okay, Juan David. So please, guys, raise your hands. But
I have my hand right. Oh, sorry, teacher.
Yeah, no. I'm just telling to organize this. Raise your hand and wait for me to give you the opportunity to speak. Sorry. Okay, but go ahead, Juan David, no problem.
Okay,
and then Andres Julian. Okay, Juan David.
I have a problem with the expression because
Which expression?
fx equal to
this
W0 plus W1.
With this one. Okay.
Yeah, because this is a function with two variables.
Right. Yeah? X and Y.
It has to be f of xy equal to W0 W1x plus W2y. Yeah, this is a plane. For my knowledge.
Right.
This is a plane.
But okay. That's good point, Juan David. Let me explain why we are doing this.
Okay.
See what's our problem. We want to build a function like this. Okay, that receives two inputs. Which inputs? X and Y, right? And that returns a prediction, okay? Positive or negative. That's what I want to build, okay? That's what I want to build, okay? That's my classifier model. I receive the inputs and I receive and I return the prediction, the class, okay? Similar to what we did with this. I receive a new point, X and Y, and I have to say if it is blue or red, okay? Blue or red, okay? That's why. So we are saying, okay, let's use a linear model. So here we are using a linear model, okay? Which is a linear combination of, not linear combination, this is a linear function over these parameters, over X, Y, okay? So that's the reason that we are using this function, okay? But you are totally right, Juan David. This actually defines a hyperplane. Where?
Yeah.
Where is that hyperplane? So actually what happens is that this function lives in a three-dimensional space, which is this one. Sorry. Okay, let's do it here. Okay. So this is X, this is Y, and this one is f of, sorry, actually here, I just noticed that this is a function of x and y.
Yeah, that was my point. Yeah.
Oh, okay, thank you. Okay, and this is f of x and y, okay? Okay, so yeah, and that's a hyperplane here. Okay, that's a hyperplane here somewhere. Okay, yeah, that's right. So going back to my question, so sorry, some people had their hands raised, and I didn't notice. But okay, Juan David, do you want to say something?
No, sorry.
Okay, good. Great. So I already saw in the chat some answers. For instance, Juan Sebastián Malagón is saying that B is equal to W0 divided by W2 and A is equal to that. How do you get that, Juan Sebastián?
Simplifying the equation.
How?
Pass y to the other side.
No. But which equation? I mean, if you take this question, this equation or this expression,
yeah,
it has f of x and y. But I see that you get rid of that. How?
Excuse me, I can.
Yeah, how do you simplify? How is the process?
Yeah, I said that. Pass the y to the other side and.
Okay, see, if I want to, for instance, if I will simplify this.
Yeah.
You say, for instance, move the W0 here. So it's y minus W0. Is that what you mean?
Yeah.
So but my question for you is what happened to this?
F is equal to 0, no?
Okay. Why? Yeah, that's super important. That's super important.
The idea is when you are seeing the plane, yeah, the idea is that you can, I don't know how to say that in English.
Say in Spanish.
Perfecto. Cuando tienes el plano, la idea es sencilla, es que en la línea, la ecuación da 0. Así de sencillo, porque si lo ves en 2 dimensiones, pues piénsalo como si tuvieras una línea en 2 dimensiones. La ecuación W más W1 por X tiene que ser igual a Y. Eso es lo que estamos viendo en el plano.
So there is something very important in what Juan Sebastián is saying here, is that the boundary is given by the values where this function evaluates to 0. Why? Because implicitly, we didn't say that before, but we are saying it right now. When this function is positive, my prediction is positive. When this function is negative, my prediction is negative, right? So implicitly, what happens is that the boundary is exactly where the function is equal to 0, okay? So if we make the function equal to 0, what we get, as Juan Sebastián said, is that A will be, let's see. So we just simplify. Let's do the algebra quickly here. Let me erase this. Okay, and what we get here is something like this. Let me move this somewhere. Okay, so what we get is something like this. Okay, this is, I can move, sorry, I erase y here. Oh, yeah, I see it here, list. Okay, so this is y is equal to, y is equal to minus W0 plus W1 x, right, divided by W2. That's right?
Minus W1.
Oh, sorry, yeah, you're right. Minus W1, right? So that means that B is equal to minus W0 divided by W2, and A is equal to minus W1 divided by W2. Okay, so that's right. And I think that's exactly what I forgot. Juan Sebastian wrote. Juan Sebastian Malagón wrote in the chat. Okay, is that clear? Okay, but see, this is just one way to address this problem. There are several ways, okay? For instance, one way to build a classifier with this, I can store all these points, right? And if I have a new point that I want to classify, for instance, let's say a point like this. Yeah, this is a new point that I want to classify. I look around that point. So I look around. Okay, in a neighborhood, okay, at that point. And I see that the neighbors are blue, so I classify the point as blue. Anybody knows how this classifier is known?
KNN.
KNN, K nearest neighbor. Okay, so that's another way to build a classifier. Anybody can tell me another way which is different to this, to what we have discussed, or the algorithms that you know, or methods that you know? Clustering, yeah, you can use clustering. That's similar to what somebody asked before. What I can start like ignoring the labels and finding groups, and then looking at those groups and what are the labels of the points in those groups. Yeah. Another way, let's see where you are saying in the chat. Support vector machines. Actually, support vector machines is equivalent to what we are doing here. It's just a different way to find W0, W1, and W2. Okay, but it's a linear model. Okay. Yeah, it's also a line. Yeah, but actually, support vector machine has a trick that you can do things different to lines, like non-linear classification using kernel. We will discuss that, by the way. Decision trees is a totally different way of addressing this point, because the model is not a line anymore. It's an structure, which is a tree, a decision tree, by the way. Okay, so, but good. This was just to see what were the intuitions that you have about solving this problem. So actually, this way to solve it, like defining a function, this is called a discrimination function. The function that for some class it gives me positive values, for other class negative values, is a very standard way to address this problem. Okay. Okay, K-means is a way of doing clustering, by the way, okay? Okay, so basically what we discuss is something like this. So we built a function, is what I was calling as a discriminative or discrimination function. And this function will tell me if it is positive, which is the positive class. If it is negative, this is the negative class. But this function could be anything, okay? Could be anything. But we were assuming that it was linear in the previous discussion, right? Okay, so for instance, okay, so we have a training data set. Okay, this is my input. So what's a training data set? It's a set of points, input points with labels, okay? And I have n of those, okay? Okay, so for instance, these are examples of a particular training data set where the labels are represented with -1 for the negative class and 1 for the positive class, okay? Okay, and then what we do, somebody mentioned that we defined a error function or loss function, okay? So somebody is raising, yeah, John Sebastian.
Yes, teacher, when you say to build a function, maybe I think it's more like approximate a function. Approximate to a function.
Right. Yeah, but yeah, build is a very general word, right? Yeah, but probably, yeah, let me see what's a better word for that. Yeah, probably find. Probably find will be like a better word for that. Okay, find. Okay, we need to find a function. Okay, that does this. Okay, okay, yeah. Okay, thank you. So, yeah, we in order to find or to approximate. Yeah, the thing that I don't like about approximate is that is because you are approximating something that actually, but we don't have that something that we want to approximate. Really, we just need to find a function that is able to do this. And there are many candidates to do that, okay? That's why probably approximate is not a good word for that. Okay, so yeah, we need to find that function, and finding that function means finding the parameters of that function. Okay, and in order to do that, we will define the loss function. Okay, the loss function tell us how good my function is. So there are different ways to do it. This is a way. This is a way to do it. So anybody can explain me how this works? That doesn't make sense. This function here. Does it make sense? What's that doing? What that function is doing? Anybody can tell me? So remember, yeah, Luis Alejandro.
He's taking, for example, even if we classify as 1 and 0, for example, in logistic regression, for example, we have a value between 0 and 1, and we can minus the real value and the predicted value. So we can plus all these values that we are getting, and we want to minimize this value.
Yeah, no, but let's don't talk about minimize, because that's what we are going to do. But okay. Yeah, at the end, you are getting a number here. My question is, what that number means? For instance, if I get a 5, what does it mean to get a 5 here? What does it mean?
The error, for example.
Yeah, well, how do you define errors? Let's say I get a 5. Yeah, exactly a 5 here. I get a 5. So what does it mean? That 5 what? 5 what? For instance, Andres Julian say that there are more positive points. What does it mean? In the chat.
Perdón, profe, intervendré en español. Lo que entiendo de la función de pérdida es que, pues, si te da un 5, lo que está diciendo es que si determinamos que el azul es positivo, estamos diciendo que el comportamiento de todo el conjunto tiende a acercarse a ser más azul que rojo. Eso es lo que estoy entendiendo. Entre mayor sea el grado...
Yeah, but no, I just want to know 5 what? Exactly 5 what? 5 is quantifying what? Yeah? 5 what? Yeah, it's not telling me if it's more positive or more negative. No. Okay? Juan Sebastián Malagón.
I'm writing in the chat. Maybe the distance between the expected and real value.
The distance. Okay. The distance. Okay. Okay. Yeah. So 5 means that the function is like 5 points away from what?
5 means that you have
yeah, a loss function is like a kind of distance. How far are you from the right answer? Yeah. But I want something more precise. What are you quantifying with those 5? So 5 is counting what? Juan Sebastián Hernandez.
What I see is the 5 means that the sum sum of the
Mhm.
all the points that in the domain.
In the nodes, not the domain.
eh,
Remember, not the domain. The training data set. You are
okay.
summing over the points or samples in the training data set. Okay.
From
So-
the training data, that's the prediction. I mean the F function, the prediction. Is just looking at that. Is one if is there a difference?
Okay.
It's zero. It's not a difference. The prediction and the label and the result. But I cannot. I'm not sure about the divided in two. I don't
Okay, but what you are saying is this:
see what's
that this is something
why
which
there.
is okay. We will check. So you are saying that this expression inside the sum is 1 if f is grown and 0
Yes.
if it is right. Is that what you're saying?
Yes.
Okay. Yeah, you are right.
Yes.
You are right. So, but you are not sure why it works. But yeah, we will see. And see that this is counting. So, actually, what this is counting is what, Juan Sebas? Okay, Tedis.
Profe, esta función, como la interpreto, parece que estuviera contando las veces que nuestra función no es acorde con el valor esperado.
Right.
Entonces, básicamente lo que estamos obteniendo es las veces que falla.
Exactly, Tedis. Exactly. So, and this is because what Sebastian said. The term inside is 1 when f is grown and is 0 if it is right. You calculate that for all the samples